Yeah, hi Vikas. Hello. Uh, Hello.
Yeah, hi.
Yeah, hi.
So who?
Yes, that guy is not joining. Just a moment. He's calling, I think. Hello. Hello. Ah, ఓయ్ నేను క్లాస్లో ఉన్నా పెట్టి హలో ఎస్ వికాస్
Yeah, hi.
సో విల్ స్టార్ట్
Okay.
యా
So it's just you and me.
ఎస్
Okay.
నో ఇష్యూస్ రైట్ actually we
So what do you do actually?
I okay, I think one or two guys are joining. Wait for a moment. Okay,
Okay.
okay. Actually, 2 days back only we have a demo. Okay, so
Okay. So you already had one demo.
right, and I didn't share with so many guys.
Okay. Okay. Okay.
Only that SAS group and actually this is for offline. One guy inquired of offline. He asked me only this time is possible. So the
Mm-hmm.
I thought why can't I share the same thing with the group if anybody can. Okay. So just a moment.
Mm-hmm. Mm-hmm.
Sorry guys. This is the introductory. Yeah. So one more guy joined. We'll just yeah. I am a date. So Biru. Hi Biru. Okay. Okay. You can say hi if you can't. If you are muted.
Hi Janardhan, hi.
Hi. So just we'll go through some of the intro today about the Spark, right? And I myself, Janardhan, I'm a data scientist by profession. I have around 4 years of experience in Hadoop. Recently became data scientist. Right now I am working as a data scientist on data modeling
Mm.
and Hadoop Spark. Uh, Data
Okay.
modeling is basically a R in R language, generally people do. So that is my profession. So I do teach in the mornings and evenings and weekends, just ad hoc trainer.
Good. Okay. That's awesome. Okay.
Yeah. So around 7.5 years of experience in IT, completely into data warehousing and Hadoop, data analysis, and
Mm-hmm.
now data science. Okay. So that's thing. Mm, shall we? So what is UPP's background, Vikas and Viru?
So means same. I means have a work experience of around 11 years.
Okay.
So when I joined the corporates, means I was more of data scientist only, working in SaaS.
Mm.
Right, then means in my second company,
Mm-hmm.
I uh, actually got transferred to analytics group.
Okay.
So now I'm into analytics from last 4-5 years.
Okay.
So means actually people are pulling off from SaaS, and so R is there in the market, Spark is there.
Mm-hmm.
So there, means so got interested in it means when I looked at means your invite, I
Mm-hmm.
thought it should be good
Yeah.
to know means what Spark is all about. Yeah.
Yeah, definitely. Spark is actually supporting R in big way. So
Okay.
that is the thing. Yeah. So what about you are Vikas, right?
Yes.
Yeah, Biru, what about you?
I'm Viruppa. I totally have 6 years of experience in IT. Hello, can you hear me? Hello, Janardhan.
I can hear you.
Hello, Vikas.
Yeah, hi Biru, I can hear you.
Yeah, okay. Yeah, right now I'm working as a Hadoop developer from past 3 years.
Okay.
Hello. Yeah.
Let's start. Yeah. So
Please.
yes, I will be I will be taking help of Notepad to explain some of the things here. So as we know, Hadoop and Spark both are complementary to each other. Hi Rakesh. Okay, so just we are starting. Hi Rakesh, we are just starting. Just please join us. I will go about your intro later on. Okay. So what is Spark? I will explain now. Okay. So we'll start with the Hadoop and distributed systems and how the Spark and Hadoop are different to each other or complementary to each other, and how they are going right now, and what is the future and what is the use for us if we learn that. We'll go through this. Okay. So Hadoop is what? Data processing framework. It is a framework simply for data storage and processing, right? And we know that data storage is in HDFS, and that is a file system. So file system won't play very big role in performances and other things. It plays a little bit role, but not too much. So when it comes to processing, so what is the processing we use? I think you people know already. MapReduce, right? So MapReduce framework we use for the data processing. Okay, MR. So this particular MapReduce framework is not so famous. That means it is batch oriented. Okay. So that is what the Hadoop is. So now I will go into the slides and why the Spark came. So the what is the main feature of it is best for the batch and data warehousing kind of DWH. Data warehousing projects. It is very good. It does the batch processing on huge data very fast and quick. So now what is the need of goal of the Spark? Simply one line, that is low latency interactive queries on historical data. So with batch processing systems, you cannot do anything interactive. It will take a lot of time, at least 2 minutes, 3 minutes. Even the data is it is not so huge also. It takes a lot of okay. So the counter one is how to make the things faster, how to make interactive. So that is by using the Spark we can achieve that. So yeah, somebody is talking in the background. Okay. Any one of you, I think one of you has to mute. Okay, thank you. Yeah. So the low latency queries. So what are the examples? Some of the examples, if we see, we want very active uh, interactive analysis on fraud. For example, how many transactions which are going online might be fraud. I want to check using per se PayPal or Paytm. Then if it takes lot of time, I don't have that much time, hours or half an hour or so. I have to detect the fraud and take the action in a relatively short time. So that is the interactive query, right? So in the same way, identity threat, okay? So across the globe, for example, any company is there and so many people are coming and inside the premises and going outside the premises. So how many people did the identity threat? So this kind of interactive things, always data will be relatively smaller in compare with huge historical data, but we have to do very interactive. Okay, so these are the some of the use cases where we need to use very interactive, and stock markets also one of the area where very much interactive analytics is required. Relatively like 1 year data we can take and compare, and we can predict for the next 5 minutes or so, or we can predict for the next minute also, just a prediction based on near real time data. Okay, so these are some of the reasons or needs in current scenarios to go into the faster processing system than MapReduce and Hadoop. Okay, anomaly detection is also one of the scenario where spam mails detection and all these things, where we don't have much time to do that, and then also we have to go for the interactive data processing. So what is right now scenario is infrastructure is there for data processing. Everything is concentrated around the batch processings. So these are things. So cluster will be there, HDFC storage, and on top of it data processing frameworks and application frameworks, right? So HBase is a bit interactive, but still it has a no very fast processing system like Spark. It is just like database. If you include that HBase with the Java and other things, then it will work good. Okay, so these are three different things. One is batch, another one is interactive, another one is streaming. So streaming applications, for example, lot of advertisement data is coming from many sources, and I am the advertising agency to handle huge data and process it. How the different clients ads are performing online. Then that is streaming data, lot of transactions, everything ads are going on in every website, and I have to analyze that data. That is streaming. And interactive we have just seen, and batch is data warehousing kind of thing, reports, dashboards, and something where like not too dynamic. So right now we are dealing all of these three things. Yeah,
Sorry to interrupt. I had one question.
yeah,
I didn't get difference between interactive and streaming. So
yeah.
interactive also we live data, right? And streaming also is live data. So what is the
uh,
difference between these?
yes, there is a big difference is there. I will just tell you. Interactive means you want the output faster. Okay, data might be coming from the database and fixed sources, not definite, not necessarily from the streaming. Okay, so interactive means how much time
Okay.
you will wait for the results. Okay, and streaming is
Okay.
what is the speed of the data, right? So I can handle streaming
Okay.
data even in batch systems when the latency is high. That means there is no problem even the report comes after half an hour or 1 hour. Then whatever the streaming data is there, I will just capture that using Flume or anything, any tool, Kafka or any tool, and then I will put that into HDFS and run the report. For 10-15 minutes I will get the report. Total maybe it will take half an hour to 1 hour. That I am able to handle the streaming data in a batch way, right? So there also I am getting the reports and these
Okay.
things, but the time taken for the analyzing, right, output is high in a batch mode, right? So that is streaming is how much speed data is coming, continuous data is coming. So how you will handle that is up to you.
So in case of streaming, is it? So we don't persist the data.
We will
Is
persist.
it? Am I correct?
Yes, we persist.
Okay.
We persist data. As soon
Okay.
as it touches the layer of Hadoop, we persist in both Spark and Hadoop. When it touches our point, and generally for streaming data, we use in between Kafka. Okay, so first touch point will be Kafka because every data is not required by everyone, right? So might be 3-4 applications are there, and certain data will go to the one application and another like that. So and after that is a pub sub model. So once the data, relevant data comes to the system of processing system like Hadoop or Spark, it will first go and store in some place, okay, in HDFS particular location, and then only I will start processing. So in which way I want to process, that is up to me. Whether I will run a MapReduce job or I will run a interactive processing using the streaming platforms. That is, Storm is there right now, very proven streaming application processing system, but it works on top of the like it is a kind of application, and this thing it works on top of HDFS. So there is no a very fast integration like Spark. Okay, Spark handles that thing in a Spark streaming. Clear? Yeah.
Okay, got it.
Yeah.
Okay, tell me.
Okay. So here unification is done at the Spark level. So right now we have different systems for batch, interactive, and streaming. And with the Spark, I can do interactive and streaming and batch all of them together. So I will show which tools help us in unifying the platform. But the Spark combines all the three. Okay, so it is very easy to develop a programs. It follows a new set of programming languages called functional oriented. So functional programming languages, so support for them is more in Spark. So even Java 8 gives the functional support, and Scala and Python, Haskell, and many other functional languages. In Spark, they are giving support to three of them: Java 8 and Scala, Python. So because of that, developers can do very concise programs. So with less code, more they can achieve more. Comparatively with the object-oriented languages, functional programming languages does the things very easy. With very less code, I can achieve many more things. And third thing is, it is compatible with all the file systems and ecosystems like Hadoop and NoSQL databases. So it is compatible with all the NoSQL databases and Hadoop also. So it works along with them. So what is Spark is? It is in-memory interactive data analysis. Okay. So to make the things faster and interactive, Spark uses most of the times memory for input output, and even for the persistence also many times we use in memory. So in the RAM itself my output can be stored, not everything but at least some of the objects for the further processing, but complete processing will be done in the in memory, not like a map reduce where after each phase we will go into the input file system and comes back. Okay, so why it will use the memory that much? Okay, so the first thing is memory is very cheap now, so we have that availability of lot of memory, and to make it speed, fast processing, so in memory is much better than the file system. Okay, so and what are the other reasons? So this is how the speeds and in data centers and all. So lot of cores, lot of data, and processing will be GBs per second, and networking is very high. So in this environment, using memory is very efficient. Okay, so memory transfer rates are very high if we have do the in memory. Okay, so lot of lot of data sets or tables can be fit into the memory, because now we have lot of
Hi, Janardhan.
RAM.
Actually,
Yes, yes,
yes, sorry to disturb.
yes.
So actually, I have to leave for office.
Oh no.
So can we actually? So I thought, means it's 8:30 to 9.
Oh yeah,
So
yeah.
so can we speak? Means I'll try and speak with you offline,
Yeah, yeah, no issues.
right?
I will share
And then
a recording with you. Okay. If yeah.
okay, cool, sure, that'll be great. Yeah, means and we'll take we'll talk offline, and I'll tell you my requirements,
Yeah.
and then means we can
Yeah, yeah. It is Biru.
further, right?
Vikas or Biru? Hello.
It's me, Vikas.
Okay, okay, Vikas. Yeah. Sorry, actually, I was in fully in this.
No problem, no problem. Yeah.
Okay, Vikas.
Nah, this actually looks interested to me.
Yeah.
So, but I'll speak with you.
Yeah, yeah. Definitely, definitely.
Thanks. Bye.
Yeah. Bye. Okay, okay, guys. If any doubt, let me clarify. Okay. So the interactive and streaming applications are done in the in-memory in Spark. Okay, I will just go forward. So the other main point is to increase the parallelism. So how it can be increase the parallelism is by running the lot of processes. When the data is in the memory, then we can do it quickly. So if that is not in the memory, then lot of memory resources will go into getting the data into the memory and those things. So if it is in memory already data, then running a application will become much easier. Okay, so that is what the parallelism, increase in the parallelism. So communication is also very less between the processes, so that work is done fastly. So it is almost follows the no share mechanism. So one process won't depend on another process or any locking mechanism or anything. Only some of the broadcast variables will be there. Those are just variables. So just a kind of values to be available for every process. Other than that, nothing will be shared. And broadcast variables are generally fixed. It is not like changing by one process and other thing. Locking mechanism is not required. It is just availability, read only variable kind of thing. Okay. So many times, if we want the accuracy, we will lose the fastness. And if it is very fast, it might not be accurate. That things happen in processing systems. But Spark does both, okay, in very efficient way, because it is following all the principles of Hadoop, like fault tolerance and other things. It has created its own mechanism on top of the file system called RDD. Due to that, the trade-off is not there between the accuracy and response time. It will give very good response, and it is also accurate. So this is the Moore's theorem. It will the memory is getting doubled every 18 months. So storage is getting doubled every 36 months. So that means for the same cost. So it is better to depend on the in memory for at least important applications, because it is getting cheaper very fastly. Already storage is cheaper, so it won't decrease further much. So, but still accuracy is the one of the challenge we face. But RDDs and Spark does the best in this. So it will give the interactive ones, and also response time is very good. Okay. Now we came to the actual components of Spark. What will be there in Spark, and what is the importance of each component at the infrastructure level, and resource management, storage, data processing, and application. We know already storage level. There is HDFS will be there. Okay, one of that. So how these are the resource management is done. So Yarn could be one of them. So it is if it uses the Hadoop, and data management is like HDFS, and data processing and applications. This differs in Spark. So we'll see what exactly is the AMPLab project and how the Spark came. So it launched in 2011 as a project. So many research students or faculty in Berkeley University. University of California, Berkeley is one of the topmost university in the world. There they have started this open source project. Okay, in their labs, AMP labs. Okay, so they have collaborated this many people, and they came up with very nice set of tools. So all are related to Spark. So many companies gave the funding, and it came out in very successful way. Sorry. So the goal is this. So whatever the pitfalls or the drawbacks of Hadoop are there, they have to fill that gap. So it is completely data analytic stack. Okay, so this is the existing stack, and the new stack, how it looks, we'll see. So they have replaced resource management with the Mesos, and it is also a file management system. And MapReduce with Spark. Okay, and on top of Spark there is streaming, and there is a Spark SQL. The Shark is nothing but a SQL component, and also we have optimization framework called Tachyon, and there is a NoSQL database, BlinkDB, and graph processing. So these are the different components of Spark. So this many things we can do in one single application, in one single code. We can write all of the codes together. That is the unification means. So within the application, so we can do all of these things. Okay.
Jonathan, I have a question.
Yeah.
Jonathan, so here has it replaced Yarn? So what is it replaced? Mesos?
Okay, Mesos is a resource management plus file system also. Okay, so Mesos does whatever the in the job tracker, task tracker things. What are that is resource management, right? So
Okay.
in Yarn also we have resource manager. correct?
Yes.
So like that, Mesos does the resource management, both the main memory and the disk. Okay,
Okay.
yeah. Rakesh, any doubts?
Yeah, it was me, Rakesh. I just asked the question.
Oh, okay. Biru?
Yeah, no doubt, sir.
Okay, Biru, we'll go on. So clear, right, until now? So this is the overall picture. So here the Tachyon is optimization framework, which is a very recent addition. This kind of things are not at all there in Hadoop. Okay. Okay. So
Okay.
instead of Shark, you can read it as a SQL. Okay, Spark SQL or so just to remember easily. Okay. So streaming, we know what
Mm-hmm.
what it does, and graph means graph processing. Okay, any graph related things, and there is machine learning, that MLib. Okay, MLBAS, that ML base is there, right? That is nothing but machine learning library, MLib. And BlinkDB is a general purpose NoSQL database on top of the Spark. It is a native, and the collaboration or working with the different NoSQL databases is not provided here. Okay. So apart from this, it can work on any NoSQL database.
Hmm.
Okay. So
Okay.
so that is what support is there in HDFS to HDFS and also to Hive. That means we can easily work with Hive from Spark. Very easily. Just one line of code. We have to just open a connection kind of thing. One object you have to create. So there is a compatibility layer for Hadoop. So if you see this picture, everything is there for Hadoop is there beside, and we have just added one more layer, right? So
Yeah,
so
Spark layer.
yeah, that means Spark and Hadoop go together always. It is not like
Mm-hmm.
many people say Spark versus Hadoop, right? If you see this picture, you will definitely remember in that way, right? In the same cluster,
Yeah.
we do have everything, okay? And in the process frameworks also, software frameworks also, they interact with each other very easily. Okay. So this is the support given to different file systems. You can use Amazon S3,
Mm-hmm.
Amazon Web Services, instead of HDFS. You can use the network file system of MapR. You can use the IBM's
Mm-hmm.
NFS. IBM NFS is different file system.
Insights.
No, file system. They have their own distributed file system
Mm-hmm.
like HDFS. MapR has its own,
Mm-hmm.
and
Yeah,
different.
Mapper is also one, but what is the IBM NFS?
Exactly, I don't remember, but they have their own file system. They give support in big insight. Support is there for HDFS, but they prefer their own file system.
Mm-hmm.
So like MapR, right? MapR is telling they won't do HDFS at all most of the times. So preferences will be given for their own things. So Spark works with every kind of file system because of the Mesos. And RDD is also one of the layer on top of the file system. Okay. So input, not just from the file format support, input can be taken from all the APIs.
Hello?
Yeah.
Voice is not clear, Jonathan.
Oh, how is it now? Hello. Am I
Hello?
clear now? Hello. Just a moment. Let me check my audio.
Voice is not clear.
Hello.
Janardhan, you're audible to me.
Yeah. Okay.
Your voice is breaking.
Hello. Is it fine?
Janardhan, your voice is breaking.
Can you reconnect?
Hello?
Yeah. Hello.
Yeah, your voice is breaking, Janardhan.
Okay. Can you reconnect?
Hello?
Yeah. Yeah. Please reconnect. If you are still not audible, please reconnect. Okay, because clear, right? For you?
Yes.
Okay. Yes, because you got the overall picture. So it is for a very fast system, Spark, and it supports major languages. And if you see here, it is supporting majority of the APIs. Whether data is coming from Kafka, Flume, or Twitter, or any other API, and also from the file systems like HDFS and other things. So broad category of input things are done, and storage formats also supporting. And moreover, it is able to work along with the Hadoop. So that is the reason why many people are preferring the Spark as a one of the tool in their project. That means without disturbing the current things, you can add one more. Okay. So for
Okay.
the another type of applications, correct? So yeah.
Okay.
Okay, because specifically you are from which background?
I am from data warehousing background, but currently working in Hadoop.
Okay, okay, nice. So you have been old student of Shashi or what?
No, I am not aware of Shashi.
Okay, 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 no issues. I thought
No.
uh, maybe you
Okay.
learned
He
Hadoop.
is Hadoop.
Yeah.
Okay. Okay.
Okay, no issues. Yeah. Okay, Biru, are you clear now? Is it clear for you? Audio quality? I think so. Okay, I'm going to the next slide. So in summary, it is just for two purposes. One is interactive and very fast, and another one is handling the streaming and other type of low latency applications in unified manner. Okay, so the unification is nothing but in single code. If I can write for say Hive code and Pig code together, that is not possible in Hadoop, right? But if we can, that is called unification. In the same code, in single file, if I write MapReduce, Pig, Hive, all of them together, one is using input of other things and all. If that can be, if we make that as a possible thing, then we can say that Hadoop is a unified platform. But that is not possible in Hadoop. So Spark, uh, Spark does that. You can write SQL queries. You can write the processing framework transformations and other things as a RDDs and transformations, and you can write the machine learning in the same next line, and you can write the streaming in the same next line, and you can go in between these four things at any number of times. So that is the major advantage. Okay. So it is very easy.
Okay.
Yeah. Okay. So it is giving support to Scala, Python and Java, and now it is supporting R also in very big way. It is open source and so many new projects are coming. Okay. So this is the thing. So right now I will show you what I teach as part of the curriculum. Okay. So as part of the curriculum, it is 30 hours session. Sessions will be there, and we'll start with Scala introduction, and we'll go into the Scala. So basically in Scala, functional programming features are the most important, and yes, yeah. Okay, we'll start with the Scala intro, and then we will go into the Spark core like RDDs and other transformations, actions, working with different file systems, different type of files. Okay, and then we'll go into Spark SQL and working with MongoDB and Cassandra. So Spark SQL means by default we will be taking data from Hive, and apart from Hive we can take data from MongoDB or Cassandra, and then working with the streaming applications. And then machine learning libraries are there, mlib and GraphX is there. Okay, so we'll go in between here. After Spark SQL, we will see what are the optimizations. So different frameworks are there for optimization, just like Tachyon. Okay, so different there is completely everything is new apart from Hadoop. How Hadoop works and Spark works is entirely different. So file storage level optimizations are there, and query optimizations also there. Okay, so this is the thing. So mostly we will start the classes in the evening time for this batch. Vikas, are you okay? Hello?
I think Vikas left.
Yeah?
Vikas is not there.
Vikas
Oh,
is okay.
sorry. Rakesh?
Yeah, I have some questions.
Yeah, okay. Let me know.
So,
Yeah, Biru?
how are you going to please?
Hello?
Yeah, Biru, are you interested in learning Spark? Now you know the idea. You
Yeah,
got
yeah.
an idea, right?
Yes, I got it.
Okay. So
Jonathan, I have some questions.
yeah, definitely.
Okay, so how are you going to teach this? Like you are going to teach this in some like Cloudera, or how, like which subject that you are going
Yes.
to teach?
Actually, in Cloudera and Hortonworks, the Hadoop distribution itself is coming with the Spark. Okay, or we can install the
Okay.
Spark in our local machine very easily.
Okay.
So if you are already working in Spark, Hadoop, better you can work in the same thing. Or if the our laptop is not supporting that much high this config and all, we can install in the local machine without Hadoop. Also we can run the Spark jobs. Okay.
Okay. Can we do all this stuff? Like
Mhm.
Yeah.
we can do that?
Then how we
So local
hello?
file system, it will make use of the local file system instead of HDFS.
Oh,
Okay.
So that is the flexibility with Spark. It can work on standalone without support of any file system,
mhm.
and it is
Then
supporting
how
all
we
of them.
can work with
Yes. Yeah. Yes, Guru.
yeah how yeah then how we can work with Spark SQL?
Spark is for
We are getting the data from Hive, right?
yeah. Then
If we are going
Hive
through
is required.
local
Yes.
system.
No, no. See,
Yeah.
Spark SQL, you can create the tables locally also. As a, we will create one kind of. There is something called case class, and we'll create the structure for the particular RDD and all. We can store back. But what I'm telling is
Mhm.
that is not the mandatory. Or you can store back in the Cassandra as a table. You can
Mhm.
store in the MongoDB. If Hadoop is not there inside the in your local machine, right? If Hadoop is
Yeah.
there, that's well and good. We are losing some.
Mhm.
We may not work with Hive and other things, right? But
Mhm.
many sometimes our limitation of these resources, and it is very slow. We may want to do some of the things in local machine, right? Even then 80 to 90% of the things we can do without Hadoop. Okay, that's what I'm
Uh,
stressing on.
General,
Yes.
how much time will we spend on Scala? So I understand that Scala is like what is the Java is to Hadoop. So we need to know good Scala to
Correct.
understand all this stuff. So how much time will be like dedicated in the course for Scala?
Yeah, we will spend a good number of hours, like 7 hours. I'm trying to spend on Scala minimum, and we are
Okay.
covering because it's a very concise language. Understanding the concepts only takes time. In Java, it is
Okay.
different. Understanding concept is very easy, but writing code is very lengthy, right? But in Scala, understanding the concept is a bit tough. But once you understood the concept, then you can write the code in very less number of lines of code will be there. Okay. So we will be putting some good number of hours in Scala. So we'll follow certain methodology like online. I'm following some Scala school and other things. So by reading, that means by self-learning some of the things, and discussing the topics in the class, the same things and all, I think we can achieve considerable progress in Scala within that 7 hours, which is required for Spark, right?
Okay.
So Spark doesn't require Scala's, connecting with databases. Scala's working with files. How you are doing with the, multi-threaded applications, web applications. Nothing is required, right? We have to know the fundamentals, how the collections works inside the Scala, how the fundamentals of this works. Like map is one of the thing, reduce, and so many concepts, correct? So that is the thing. So whatever is required for us, the fundamentals and the collections and other things, so that we will discuss. Yes. Any other
And
doubt?
about the so there will be some like some topic on machine learning as well?
Machine learning library is there. Definitely, I am going
Okay.
through that, how to make use of machine learning library. But I'm just telling you before itself, you should know what are the algorithms are, right? We'll make use of them. How to make use of them is there in the mlib, right?
Okay.
But I'm not covering the entire machine learning or anything in this. Yeah. So definitely we will cover, like for example, linear regression is there. How we can make use of the linear regression particular algorithm inside the machine learning. But what is linear regression and when it has to be used and how it works, and those things are actual machine learning classes, right? So those things we may not cover. So broadly, what type of machine learning algorithms will be there, and support in the mlib, and how we can make you calling them as a functions and other things. That we can see. Okay, I am clear that much. Okay. Yes, Biru. Okay.
Yeah, okay, okay.
Yeah.
Yeah.
So yeah, you can ping me. You both have my numbers. You people can ping me. Okay. I will
Yeah,
share the
okay.
recording also. If whether
Okay, what is,
yeah, tell me.
yeah, what about timings?
Timings. We are thinking right now in the evening. Okay.
Mm-hmm.
So it is like 7:30 or that time 8 o'clock. So I will see
Mm-hmm.
morning also there. Right now
Okay.
Hadoop classes are going on in the morning, and
Mm-hmm.
I'm thinking about starting in the morning, but the one or two guys are already there for the evening batch. Okay,
Mm-hmm.
that to start. So Spark, there is no right now online. Only offline classes are going on in Kormangla, Bangalore. So I'm going to start this week in 2 to 3 days,
Mm-hmm.
mostly in evening. If it is fine, it's okay. Otherwise,
Okay.
you can attend the morning sessions after 1 or 2 weeks.
Where it is in Kormangla?
Forum,
Forum.
yes, opposite to forum.
Which institute it is?
The ours is eCriya, EK. So I'm just writing here. Kriya. So eCriya is our. This is our website
Mm-hmm.
eCriya.us. Ours is a US based
Okay.
company. So
Mm-hmm.
we do give. We do have our own projects in US. Some of them, and we make
Mm-hmm.
resources sourcing will be done there itself. And in India also we are
Mm-hmm.
going to start some projects and all, if everything goes
Mm-hmm.
fine after Jan.
Mm-hmm.
So our training is only one part of our IKRIA.
Mm-hmm. Okay, okay. Hello.
Yeah, tell me.
Yeah, one of my friend is there. He's looking for freelance project because
Uh-huh.
hello.
Yeah, tell me.
Any freelance projects are going on?
Freelance? No. Freelance? No. We don't have any freelance projects.
Uh-huh.
Actually, how it is
Uh-huh.
that we do have a lot of resources like you people, right? Who has done
Uh-huh.
Hadoop and Spark codes and other things.
Uh-huh.
So we collaborate most
Mm.
of the times with the students only, or we give opportunities to
Mm-hmm.
them. If client needs some three people in their location full time, then
Yeah.
we'll
Uh-huh.
ask whoever comes into our this thing, we'll send it to the client place. Or if they give project to our directly to us, then we are giving it to
Yeah.
our own people who are already part of our network as part of the eCriya
Uh-huh.
project management. We don't have so-called
Uh-huh.
this one. You can Upworks is very good, right? You can directly approach.
Yeah.
So actually, I am getting
Yeah.
some calls from Upworks for part-time this thing.
Uh,
So recently I got an inquiry for converting some code from Spark to R, machine learning code. So because of the time constraints, yeah. So that is very
Correct.
tough project, but still like I'm trying to find at least some
Yeah.
time for that. So that is an open source project. You have to convert that particular Spark this thing into R. So such kind of people will definitely contact you if you put some good profile over there. Yeah. So definitely, yeah, I will inform you if anything comes to me. Okay.
Okay.
Another
Okay, Jonathan.
website.
Yeah. Tell me, Vikas. Rakesh.
What was the website that you mentioned?
And ekriya.us.
Okay.
Other like freelancing something you mentioned, right?
Yeah.
The freelancing you mentioned.
Freelancing, that is
Okay.
Upworks. So the
Sorry.
freelancer, yeah, Upworks. I am just typing it here.
Okay.
Upworks.
Okay. Okay. Got it.
Freelancer is
Oh.
there, but Upworks is much better than freelancer.
Okay. Okay. Thanks, Jonathan. I'll contact you offline to discuss further. What?
Hello?
Yeah.
So,
Yeah. Tell me.
Yeah. Are you going to close this session or no?
Yeah. We
Still
are
it is on?
closing. Yes. I'm just waiting.
Okay.
Okay.
Thanks.
Yeah. Tell me.
I'll contact you offline.
Yeah. Definitely. So I was just waiting. Any other more doubts are there?
Okay. Okay.
Okay. Yeah. Thank you.
Okay, Jonathan.
Yeah.
Bye-bye.
Okay.